go. 3.1 quadratic functions and models is where we're at. So we're now leaving linears and entering the world of quadratics.
Yeah. Quadratics a little easier than linear.
I don't know. So our goals here are to learn basic concepts about quadratic functions, complete the square to find the vertex, graph a quadratic by hand, solve applications, and then learn how to find a regression in the calculator. So quadratics. Do we remember this guy? Yes. Okay. The shape of the quadratic is called a parabola. Okay. And then you have, it's a U-shaped situation happening here. It opens upward or downward. It has a vertex and an axis of symmetry. Okay. Those are the two key features of a quadratic. It has a vertex and an axis of symmetry. So I don't know what, oh, I don't know. Did I say it wrong?
No. I thought you said absence.
Oh. So you have two types of vertex. You will either have a minimum or a maximum. Okay. So I like to call them valleys and mountains, right? Or I guess hills work, valleys and hills. I used to say mountains, but cool. And so valleys are your minimums, mountains are your maximums. Got it? All right, continuing. The quadratic function. So the quadratic function, my little fancy R didn't make it for some reason. There we go. All real numbers, okay? So our domain is all real numbers from negative infinity to positive infinity. Our range is y is greater than or equal to 0 because we have a starting point for our parent function. And there's continuity, meaning that I can trace this graph with my finger and never, ever, ever have a gap, hole, or asymptote. Does that make sense? All right. So if you look over here, here are some key features. Your line of symmetry doesn't always have to be the y-axis. Your line of symmetry just has to go through your vertex. Okay. You will always have a y-intercept, and you can have a max of 2 x-intercept, but do you have to have an x-intercept? No. Okay, it could be floating. Does this all look somewhat familiar?
Yes.
Okay. Algebra 1 and Algebra 2 all day long. And if you took pre-calc, yes. Yeah, should have seen a little bit in geometry. All right, questions about our function? Yes, this is our, It's if you don't remember it, you should write it. Yeah. All right. There are 2 forms of quadratic that we mainly deal with. There's technically 3 forms of quadratic. However, we're looking at these 2. The 2 forms that we're going to deal with are standard, which is your y equals ax squared plus bx plus c, and your vertex form, which is a times x minus h squared plus k. Each one has their own role and is useful depending on what you're doing. They both will have A. A is the same value in both. So A is going to be the same. Remember, your A tells you whether you're going to have your positive parabola. So either a happy parabola or a negative parabola, a sad parabola. So that's the job of A. That's going to be your vertical stretch or compression situation. Okay. In standard form, what you can tell just from looking at the equation is your C. Your C in your standard form is going to be your y-intercept. So from standard form, you know that C is your y-intercept. So it's 0, comma, whatever the C value is.
So what is the
A is just telling you whether you have positive or negative, and B doesn't have a real role right now. Okay. In vertex form, A is still doing the same thing, but you now have H and K, and H and K are going to be your vertex. One thing you got to remember here is that X is a liar. X is lie. So even though it looks like it's a negative H, is actually a positive. So H and K represent your vertex. Hence why it's called vertex form. All right, questions so far about either form?
You guys might show me.
Oh, my computer went to sleep. All right, so looking here, we're gonna determine whether the functions represent a linear, quadratic, or neither. If it is a quadratic, identify the leading coefficient and evaluate the function at x equals 2. All right, so A, is it a quadratic?
No. Yes.
It is. Why is A a quadratic? Because it's squared. This little 2 says that I'm dealing with a quadratic. Okay, so I'm going to simplify this. And when I simplify this, I distribute the 2 to the 3 and the x. So now I have 9x squared minus 2. And that is a quadratic, right? Because the highest power is a 2. Okay, it says identify your leading coefficient. Your leading coefficient is your A variable. What is your A variable here? 9. A equals 9. Then it says, can you evaluate f of 2? Yeah. Exactly. So evaluating, we have 9 times 2 squared minus 2. What'd you get? What's 9? What's 2 squared? What's 4 times 9? What's 36 minus 2? There you go. Genius. Okay. All right. So do we see what we did there? Yeah. All right. B, is g of x a quadratic?
Yes.
I got a yes. I got a yes. Any other yeses? And why do you say yes?
Because
Perfect. Because when I distribute that 2x, it's going to become a square. So exactly. So we have 6x squared plus 2x. So now we have the quadratic. What is our leading coefficient? 6. 6 is our A
so,
value.
Ms. Jones, the whole 2x distributed.
The whole 2x distributes. Okay, and then if I wanted to evaluate this at 2, f of 2 equals what?
Oh my gosh.
What's 2 squared?
4.
What's 4 times 6?
Well, 24.
24. What's 2 times 2?
8.
4.
Thanks.
And what's 24 plus 4? 28.
Way too fast.
Whoa, paid a little some extra.
I was going 50 and 1.
Why does it do
I
that?
don't know. It's a little special of a pen. All right, last but not least, is it a quadratic?
No, because it's in the denominator.
Perfect. It is a no.
That was such a
No.
Wow.
Okay. It is not a quadratic because the variables in the, what is it called when the variables in the denominator?
Not a function.
Oh, wait.
No, oh, wait. I thought it was proportional.
No,
No,
no.
No, wait.
no, it has a.
What type of graph?
Yeah.
Is it?
What is it called when the variable?
Identity.
No, no.
Can you give us a hint? What does it
I'm
start
just
with?
gonna say it.
What does it start with?
An R.
Rational.
It's a rational equation.
I was wrong.
It would be rational. When you have the variable in the denominator, it is a rational function.
That's not.
Okay,
Is it?
it's the opposite of a
Because
polynomial.
of ratio. That's what I was thinking of when I said,
The opposite, that one or the
What?
what is it called? The square root.
Square root function?
Yeah, is that?
Quadratic and square root are inverses.
Miss Jones, when I said fractional, I was thinking of ratios, but I couldn't think of the word ratio, and then I was like. I have it like.
All right. Okay, so we're gonna go over just reading the graph and being able to identify key parts from the graph. So if you look up here, Gregory, we have the sign of the leading coefficient. What do you think the leading coefficient here is?
3.
No, but no. What do you think the sign of it is?
Oh, the negative.
Your name's not Gregory.
Oh.
Oh, the sign of it?
Uh-huh,
Can you hear me?
The sign of it.
yeah.
What do you
Looking
mean?
at the graph, what is the sign of the leading coefficient?
It's going down, so therefore it's negative.
Okay. Because our parabola is a sad parabola, that means the leading sign is negative. So I don't know why I put an R at the end of negative. I have no clue. A negative? I don't know. I don't know why I did that. Negative. All right, next, identifying the vertex. Can we identify the vertex? 2 what? 2, 3. So the vertex is at 2, 3. That's your H and your K. And then last but not least, identifying the axis of symmetry.
2, 0.
At x equals 2. Perfect.
2, 0, that's it.
It's not. It's not. It's at x equals 2 because that's where my imaginary line would be.
Would it just be your max?
No, your vertex, it would be your maximum. Your axis of symmetry is always the x value of your vertex. Yes, it's always the H. All right. How do we feel about reading a graph? Doable, okay? Okay. All right, now we're gonna keep reading it. We're gonna talk about where is it increasing? Just like you read a book, you read a graph from left to right. So reading from left to right until when? Where's my axis of symmetry?
2.
2. So I increase from negative infinity to 2, negative infinity to 2, and I decrease from 2 to infinity. Everything is defined by the x and always use parentheses.
Is that the same
Okay.
graph as the last graph?
Yes.
Okay.
It's the same graph. Okay, everything is defined by the x because that's your independent, and you're going to always use parentheses when you're describing the intervals of increase, decrease, or constant. Okay, how we feel? Simple for right now. I'll take it. Doable? Okay. All right. Now we're going to go dive a little deeper. So we're going to write the vertex form of the graph. Okay. We're going to go through the steps for finding the vertex. And yeah. So the first thing you do is identify the vertex. So step 1 is, what is your vertex? -1, 3. So -1, -3 is our vertex. Agree? Okay, that's step 1. Questions, comments, or concerns? Okay, step 2 is you want to use your y-intercept if possible, or any given point. So in this case, do we have a y-intercept? Yeah, what's our y-intercept? 0, -1 is our y-intercept. Step 3 is to solve for A. I didn't mean to capitalize it. And to solve for A, we're going to use our vertex form. So we know that y equals A times x minus h squared plus k. We're going to take the information that we have and plug it in and solve for A. So we have our h, our k, we have an x, and we have a y. So we're plugging those values in. So we have -1 equals A times 0 minus -1 squared minus 3. So I plugged in everything that I got from steps 1 and step 2. Still with me? So a negative times a negative is a positive. So we have -1 equals A minus 3. Because 1 squared is just what?
So then,
1.
where the 0 and the 1 is inside of brackets, they both turn positive.
The 0 was already positive, but a negative times a negative made the 1 a positive.
Wouldn't it be a squared though?
Cause in the formula, it already has.
It's 0 plus 1 and then square that. So what's 0 plus 1? 1. And then what's 1 squared? 1. All right, what's the last thing I need to do to get my a by itself? Add 3 to both sides. And when I add 3 to both sides, what does a equal? 2. So now we know the value of our a. So step 4 is to plug in your h, your k, and your a. So we have y equals 2 times x plus 1 squared minus 3. And that is the equation of the vertex, of the quadratic.
So you put that in the calculator, right?
You're done.
Oh.
It says write the vertex
Oh.
form of the graph, and we wrote the vertex form of the graph. Just
So why do we gotta leave out the line of X? Oh,
because y and x can be anything, right?
How many left are like?
5. 5, maybe 6. I wrote 6 up there.
yeah.
On the, were the purple guys?
Uh-huh.
Like, so we just like take out the one?
Yes, because you're
But then I-
no, because it's multiplication then subtraction. So this technically is just a times 1, but is there any reason for me to write a times 1? It's an understood one. All right, good questions. Any other questions about taking the graph from vertex, from the graph and creating the vertex form? Okay, you identify the vertex, identify the y-intercept, solve for a, plug in just your h, k, and a. Okay,
Oh, good job. This won't work.
all right. So here it says, what if we're given our function and we want to make it into standard? So we are given the vertex. And we want to go into standard. So you have your vertex and you want to convert it to standard. Uh-oh. So the first thing we're going to do is, all you're going to do is simplify. So the goal is, oh, whoa, my pen's doing things. I'm not doing that. Oh, pen, stop.
No.
We don't want that.
Why'd you draw it?
I did it. I did it so. All right, here we go. So the first thing you want to do is just simplify. All you're doing is to get this into that is you're going to FOIL, distribute, combine like terms, okay? So the steps that we're going to first do is we're going to FOIL, distribute, combine like terms. So we're going to FOIL. How do I know I have to FOIL?
First,
No, why do I know I have to FOIL? Because what does that that little 2 mean? I have how many of those? There's
yeah.
2 of
Each
them.
other.
So the first thing we're gonna do is expand this to write it as -2 times x plus 2 times x plus 2 minus 3. Which is why we have to FOIL, because x plus 2 squared means I have 2 of them. So I FOIL or distribute, multiple distribution. So when I distribute x times x, I get x squared. X times 2, I get 2x. 2 times x is, and 2 times 2 is 4. Okay. How do we feel about the step of FOIL? So all we did here was FOIL, double distribute.
Wait. Why didn't you just do the -2?
We have to do FOIL before we can distribute. Remember, you have to deal with your parentheses and exponents before you can multiply. Got it? Okay. So now we're going to distribute. So I'm distributing the -2 to everything. Is it okay as I distribute, I combine? Will that throw you off? Okay. So we have -2x squared. And 2x plus 2x makes 4x. 4x times -2 is -8x. And then -2 times 4 is going to give us -8. And all we did here was distribute. And then your last and final step is to combine like terms. What are my like terms? -8, -3. What does -8, -3 make? 11. So we have -2x squared minus 8x minus 11. And there is our standard form. So the last thing we did was combine. So FOIL, distribute, combine. Did you really just take a picture?
You recorded
Okay.
too?
Yes. FOIL, distribute, combine. Good? Doable? How do we feel?